disparity between where the action needs to happen and where the resources are to actually take the action going. Sounds familiar. I mean, that's true of climate change, lots of other issues as well, right? What else? What's distorting about a map like this? Yes?
Maybe unequal distribution of the
Exactly, exactly. So one of the fundamental things, if you remember nothing, I'm going to give you two or three things over the course of today to remember. Water is local. Water is a funny thing because it's heavy, it's difficult to transport, and so you need to have water supply where the users are and where the uses are. So water is local. So when we looked at these maps, we said, well, that doesn't tell us too much that on some average basis, U.S. has abundant supply. Like that makes a big difference if you're in Phoenix or you're in Maine, right? In terms of how much water is available. So this didn't capture the local granularity of water issues. It's tough to move water more than, in some of the studies we did, most big cities are inherently water scarce because they're so populated. So they typically draw from water from the surrounding areas, but they don't go typically beyond 300 kilometers. The economic limit of infrastructure to transport water into cities is at about 300 kilometers, where it just doesn't make sense to go further than that. Every now and then you'll hear somebody who has some harebrained scheme to take an iceberg from Greenland and pull it over to California or something. In general, water is really tough to move. The economics just don't work. So what water you have locally really matters. So the first thing that we did is we did a map of local water availability. So if you take water down to the level of 60 kilometer by 60 kilometer quadrants, how does it look different? So let's just compare it to the 2025 projection.
Yeah, less water.
Yeah, so what you thought maybe it was, oh, too bad those poor people who don't have water, suddenly pops up all over the place, right? So on a local level, the level of water scarcity is actually hidden by these statistics that are at too high of a granularity. When you look at the local level, you see a whole lot more scarcity. In the U.S., we have a relatively water abundant east and a west that's in trouble. China, you have a similar dynamic. If you look at the orange part of China, that's where all the coal and a lot of the natural resources are. So water is a huge constraint on them even being able to access a lot of the resources that they have in those regions. So this was kind of an eye opener for me to realize that there's actually a lot more latent water scarcity in the world than what we realized when we began. So water's highly unequally distributed. 6 countries in the world, and there's over 200 countries in the world, 6 of them have half the supply. The other 190 some have the other half. So huge disparities in water availability. Brazil, Russia, Canada, Indonesia, China, and Colombia. And even there, some of these countries, right, are water scarce in some parts. So highly unequally distributed. Another aspect of water is that it is almost universally poorly managed. I think because water is inexpensive, because it's highly subsidized, because it's been taken for granted. It is a domain that is really poorly managed in lots of places, and often decisions are made based on economic or political criteria that have a water impact that wasn't foreseen. So any of you know about the RLC? So a few of you saw, so I won't go into depth about this. In 1989, this is what the RLC looked like. 2003, looks like somebody pulled the plug out of the bathtub, right? And then 2009, just a bare footprint of what the lake was originally, and in a pretty short period of time. What's the story here? Yes?
Yeah, we talked about this in environment content class.
Yeah.
And this was used as an example of, we talk a lot about violent conflicts.
Yeah.
And like surrounding water. And this is an example of really not violent conflict.
Yeah.
Maybe not even conflict at all. It's actually cooperation between the countries in the region
Yeah.
over the use of the water, but that doesn't equal good use of the water.
That's right.
So yeah, the countries that draw
That's true, but that's the backstory is the Soviet Union broke down, all these former, Soviet states were independent, they all were vying for dominance, and they all thought that going into cotton production would be a good idea. So it was agricultural policy that led to massive diversion of tributaries flowing into the Aral Sea for irrigation. And so if you look, you can see this massive buildup of irrigation channels all along the tributaries flowing into here. So essentially it was sort of poor planning in terms of what kind of agricultural commodity could they base their economy around. Cotton being one that's attractive because it's profitable, but one that the ecosystem didn't actually support. So another aspect of water is the idea of virtual water or embedded water. So water isn't only the thing that flows in rivers, it's also embedded in everything that we use. So this was kind of a eureka moment for me too, where I realized, it's not just, the stream out there, it's actually my clothing, it's my watch, it's this table, it's everything that we use has an embedded amount of water in it. So for example, a cotton t-shirt, requires a lot of water because you grow the cotton first, that needs to typically be irrigated. And so it has an embedded amount of water that goes into the cotton production that produces the good. So for a cotton t-shirt, somewhere between 500 and 2,000 liters of water that's used to produce that t-shirt. A slice of cheese, 40 liters. So when you make the choice about hamburger or cheeseburger, it has pretty big impact. Even bigger if you look at the hamburger itself, which is 3,000 to 15,000 liters of water that's embedded in the grains, which feed the cow, which also consumes water, and then ultimately, produces the hamburger. So there's an enormous amount of water that's embedded in everything that we consume. A car uses about 40,000 liters of water. It has 40,000 liters of water embedded. Where in the car would you suspect that to be? Any guesses? Yes.
The cooling system?
That's interesting.
The leather.
No, leather is another good guess. Not right.
The metal.
No.
Air conditioning?
Air conditioning. We're running out of parts of cars here.
Is it
Yeah.
the windshield wipers when they're
Yeah.
press the button and it sprays up on the water? Water. It's straight water.
No, that's actually where they
Water.
get water.
Wiper fluid.
That's where they get the water from.
Is it
It's not leather.
and maybe to do with
Tires.
Tires.
Oh, rubber.
Oh,
Rubber.
yeah, I was gonna say that,
Yeah, you all had just on the tip of your tongue. I can tell. I can tell. So vulcanizing rubber is very water intensive. So again, when you see a car drive down the road, when I started studying this stuff, like, man, there's like, 4 Olympic-sized pools driving past, because of the amount of water that's embedded in these everyday things. So when you think that through, you think about what's the water impact of decisions around global trade. What kind of products get produced in what places, agricultural products or industrial products, and then how they're shipped. You're essentially shipping embedded water from one place to another. So China's playing this game right now, right? Because they have inherent water scarcity. They have 20% of the world's population. They have 6% of the world's water. So they are sourcing agricultural and other inputs that are water intensive from the rest of the world. They're signing exclusive agreements all over Africa. Everybody knows that, but I think water is actually a huge driver there. They have access to Africa's water through their produce, which can then be shipped into the country. So global trade is actually, one of the primary drivers in how water gets allocated and shifted around the world. Again, something you don't hear very much about.
Are these numbers, is it commonly, like water that is recaptured or water that is lost?
So the water is never lost, and you're right. And we'll talk about this when we get to Coca-Cola's goals, because if it's used in agriculture, that water doesn't disappear. Right? It goes into the plant, you see evapotranspire through the plant, and then goes back into the atmosphere. So you're right that that water doesn't disappear, doesn't even necessarily get polluted, but it is used, it is consumed and moved in the cycle. So how you balance those things where it's not being destroyed, but it is being altered in some ways, also matters when you use it, what season. So timing can be really critical, and place really matters. So all of those dynamics mean that the kind of metrics for good water management are quite different than what it would take to manage lots of other resources. So theoretical improvements in water productivity could reduce the demand this much. We also know that from the baseline, we may be able to get increased infrastructure to allow for better, management of supply. But we have an enormous remaining gap that we don't actually know how we're going to close. So this is the challenge over the next, 15 years, is a big gap between projected demand and supply of water. So that's the kind of, I think, imperative on, at least on the water supply side of the equation, is how do we either vastly improve our productivity, build out massive infrastructure, or find some other way of using water in our economy so that we can close this gap to achieve what we want to achieve. If we don't close that gap, it's likely to lead to more tension and conflict. It's likely to lead to reduced economic activity. So there's a lot of consequences of that. So this is the kind of mandate, I think, around addressing water demand. So let's go back to that issue of water and conflict and the comparison, water is the new oil in the 21st century. So if you look at oil and water, how are they similar? Scarce, yeah, inherently scarce. We want more of it than we have. What else?
Of water and oil.
We depend on it, absolutely. Our economies both depend on adequate access to good quality supplies of both of them, right?
Sources are often transboundary. There's obviously there's issues between which country has the right to.
Yeah. So there's the transboundary issue, and there's also just the fact that they're unequally distributed, right? Is that they are where they are and they aren't where they aren't, and that sort of sets the context. Any other similarities? Yeah. So hydropower from water, that's true, and oil obviously. So they're related to the energy system in some fundamental ways. Anything else? What about differences? Yes.
I guess technically water is renewable, right? Whereas oil is not.
Right. One's a depletable resource or non-renewable, the other's renewable. Non-substitutable. So water is non-substitutable. Oil, theoretically anyway, there's other alternatives for, powering our cars or our electricity system or whatever. So that's right. One's substitutable, one non-substitutable. What else? Yes. Yeah, one's sort of critical to survival. We've never lived without water. We lived for most of the history of humanity without oil. So that's important. Good. So, and this is not a comprehensive list, but let me just go through what I think. Both are commodities, right? So there's not, to a large extent, water is water and oil is oil. They both operate in the economy as commodities, and one unit is substitutable for another unit in most cases. So there are differences in both the quality of oil and the quality of water, but you can think about them both as being commodities. They're unequally distributed, which we talked about. We didn't talk about the requirement of massive infrastructure and capital that needs to be invested to be able to make use of them. So in both cases, it requires massive amount of money to be able to create the infrastructure to use it effectively. Now you can use water, you can go down to a river and scoop water out, but if you're going to use it to drive a global economy, an industrial economy, you need pretty massive infrastructure for storing, transporting, cleaning, all of those things. Oil the same way, so trillions of dollars of investment. So both are critical to other systems, like agriculture, for example. So they are critical enablers, and they're highly interconnected themselves. I took the slide out, but I have a slide on the connections between energy and water, because you need a lot of energy to manage water, you need a lot of water to be able to get energy. So they are highly interdependent. Both are highly regulated. We didn't talk about that. For all of you public policy folks, these are two domains that are both highly regulated, and in some really perverse ways. So even the differences between the West and the East, in the US, in the West, sort of, this is a caricature, but most of the water regimes in the West are use it or lose it. If you don't use your allocation of water, you'll lose your right to be able to secure that in the next year. So there are critical inputs to the economy, I think we said, and both are factors in global conflict. So we hit on most of those. Differences, water is local and oil is global. So we talked about how hard it is to